Good morning, ladies and gentlemen. Today we are on page 135 of your student journal, page 135. And our objective today is, today I will learn about the commutative property of multiplication. Okay, so let's talk about what this means. So today I will learn about the commutative property. Okay, and we're going to see what this means in our vocabulary. Sometimes people want to think it's commutative. They want to think there's an N there because we think of the word community. But make sure you know it's commutative. There's a T, not an N. So the commutative property of multiplication. So let's look at our vocabulary and see, what does this even mean? So the commutative property of multiplication says factors can be multiplied in any order and the product will remain the same. Okay, so remember, factors are the numbers that we're multiplying together. So here, 7 and 5 are my factors and my product is 35. So 7 times 5 equals 35 and 5 times 7 equals 35. So what they did here is they switched the order of my factors, but I still get the same answer. So that is what the commutative property means, is that you can switch the order and still get the same answer. Okay, something else that they didn't add in vocabulary was the arrays. We're going to be using arrays. So let's write that there because we're going to talk about what an array is. Okay, so I'm going to do two arrays with you because I want you to see something. So I'm going to do an array for 2 times 4. Okay, so what this means is 2 rows of 4. 2 rows of 4. So we have 1 row of 4 is 1, 2, 3, 4. And then one more row of 4. That is the array for 2 times 4. Okay, what I want you to notice about an array, ladies and gentlemen, is it should create this box. Arrays should create the box if you're doing it correctly. I'm sorry, friends, I had to go grab something really quick. Okay, so let's do another array. This time, let's do an array for 3 times 3. So again, that means we have 3 rows of 3. That's what 3 times 3 means. So let's do 1 row of 3, 2 rows of 3, and 3 rows of 3. Okay, so again, what I want you to see is those arrays have to create a box. That's going to be important in today's lesson to remember that the arrays create a box. Okay, so let's look at our steps today. It says we're going to identify the product. Remember, product means our answer or our solution. We're going to create an array. And then we're going to use the commutative property of multiplication to construct a related array. So to make one that has the same answer. Okay, so I'm going to get started, friends, on mine. Okay, so here is my first problem, which is a little weird because they just gave me a number. So they're just giving me the number 12. Okay, what they want me to do for 12 is supposed to be my product. They don't tell me that, but 12 is my product, which remember then means it's my answer. Oh, I'm sorry, friends, I should be writing in a red pen. So 12 is my product, which means that I need to come up with the factors. Okay, now that means I need to draw an array that would work. So what if that means that I need to have 12 in my array? So what if I do 1 row of 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait, is that going to work? No, because I used 12, but I don't have a nice box. So I can't do that. That's not going to work. So even though I have 12 dots, that doesn't work for me. Oh, so let's try again. Let me see if I can be more successful this time. What if I do a row of 5? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so again, I used 12, but is this going to be an array? Nope, not at all. So I have to make sure that when I do my array that I come up with a nice square shaped one. So let me try a row of 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, look friends, did it work out? Do I have a nice box-shaped array? Yes, I do. So how many rows did I have there? I have 1, 2, 3 rows. Remember, that's how I set up my problem. 3 rows of 4. So I could say 3 rows of 4, or 3 times 4 equals 12. Okay, what I should be able to say then is I should be able to switch it. What if instead I said 4 times 3 equals 12? So now, this is the commutative property, means I can switch them. So I'm going to switch my factors place. So what if I have 4 rows of 3? So let's try that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 1, 2, 3, 4 rows of 3, and I still came up with 12. That's what my commutative property says. Okay, and then remember when you do these, you have to have an array that has a nice box shape. Is there any other way that I could have come up with 12 and it would have still worked? Because we know these didn't work because that wasn't an array. What if I tried 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, that one worked. So again, I counted 12, so my product is 12, and I have a nice array. So what did I have here? I had 2 rows of 6 equals 12. Well, if that works, then I should be able to say 6 rows of 6 rows of 2 will also equal 12, because commutative property means I can switch these factors. So let's check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6 rows of 2 also equal 12. And that's a nice array. Okay, so that's going to be one type of problem that you're going to be seeing, friends, where you have to set it up and you have to come up with your equations and you have to use arrays that work. Okay, let's see a different type of problem. This one says, true or false, these arrays represent the same product. Remember, my product is my answer or my solution. If the answer is false, how would you correct it? Okay, well, let's see what the product is here. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's a product of 20. And what do I have here? I have how many rows? 1, 2, 3, 4 rows of how many are in each row? 1, 2, 3, 4, 5. 4 rows of 5 equals 20. Let's check over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. No, I have different products. And I have 1, 2, 3, 4, 5 rows of, how many is in each row? 3. So true or false? No, false. They don't have the same product. They have different products. My product is my answer. But they said, how could I correct it? What could I do to make them the same? Well, to make them the same means I have to have the same factors. So here I have a 5 and 3, and here I have a 4 and a 5. What if I get rid of this last row, and instead of 4 rows of 5, I have 3 rows of 5. What if I cross that off and now I only have 3 rows of 5? Would that work? Yes, because if you have the same factors, 3 and 5, 5 and 3, then my product's going to be the same. So that's one way I could have fixed that, is I could have got rid of a row. I'm going to show you the same problem, but I'm going to show you another way I could have fixed it. So we already know the answer was false because this is the exact same problem. And for this one, we had said we had 4 rows of 5, which equaled 20. And this one we had sorry friends. This one we had 5 rows of 3, which equaled 15. So that one didn't work because here I had a 4 and a 5 as a factor, and here I had a 5 and a 3. What if for this one, we changed it and we had 5 rows of 4 instead? So what if instead I said I have 1 row of 4, 2 rows of 4, 3 rows of 4, 4 rows of 4, and 5 rows of 4? So what if I change it by I could add more to each row. So I could have done that as well, so as long as I have the same factors, my product will be the same. Okay, friends, let's try some together. We are on page 136. Page 136, and our first problem is 15. So they're giving us the product or the answer or solution 15. And they need us to come up with an array. Well, what do I know about 15? I know that 15, I could skip count by 5s to get to 15. So I think 5 would be a good one to use. So maybe we should do a row of 5. Let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have 15. So what's my equation? How many rows do I have? 1, 2, 3. 3 rows of 1, 2, 3, 4, 5. So 3 rows of 5 equals 15. Okay, so the commutative property says we can switch those, which means we could say 5 rows of 3 should equal 15, because I should be able to switch my factors. Let's check that and see if that works. If we do 5 rows of 3. 1, 2, 3, that's row 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have 1, 2, 3, 4, 5 rows of 3 also gave me 15. So that's what that commutative property means, is we can switch our factors and we still get the same answer. Okay, let's look at our next one. It says, true or false? These arrays represent the same product. If the answer is false, how would you correct it? Okay, so let's count what our product is. So let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so our product is 20. And what's our equation? How many rows do we have? 1, 2, 3, 4, 5. We have 5 rows of what? How many is in each row? 1, 2, 3, 4. So 5 rows of 4 equals 20. Okay, let's check our next one and see if they match. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, we did get 20. So this time we have the same product. What's our equation? How many rows do we have? We have 1, 2, 3, 4 rows. 4 rows of how many? 1, 2, 3, 4, 5. 4 rows of 5 equals 20. Well, of course those would be the same because all I did was took my 2 factors and switched them. And that's what the commutative property says we're allowed to do. So that one is true. Okay, ladies and gentlemen, you're going to be trying some of these on your own. Have a great day.